Imagine a tractor built in 1938 that could automatically adjust its engine power based on load, a feature most farmers didn't see standard until the 1980s. Or a machine from 1959 that used a continuously variable transmission decades before modern tractors made it mainstream. These weren't concepts or prototypes sitting in a lab. They were real, working machines that hit the fields and completely baffled the industry. Today, we're counting down 10 old tractors that were so far ahead of their time. The world simply wasn't ready for them. Number 10. The Fowler Gyrotiller. Let's kick things off with something that looks like it was designed by a science fiction writer. The Fowler Gyrotiller was introduced in 1927 by the British firm John Fowler & Co., and it was unlike anything farmers had ever laid eyes on. This wasn't your standard plowing machine. The gyrotiller used massive rotating tines, powered by a large internal combustion engine, to till soil to depths that conventional plows simply couldn't reach. We're talking deep subsoil cultivation that broke up hardpan layers and dramatically improved drainage and root penetration. The idea was brilliant. Deep tillage meant crops could reach moisture and nutrients that shallow-tilled soil locked away. The machine itself was enormous. Some versions weighed over 20 tons and required its own fuel supply system. It was essentially a self-contained tillage powerhouse. The gyrotiller found work in tropical sugar plantations in places like Trinidad and Australia, where breaking up dense clay-based soils was a constant battle. The engineering concept, powered rotary deep tillage, wouldn't become widely adopted until the late 20th century when deep tillage subsoilers and ripper attachments became standard on large farms. Fowler was thinking about soil health and root zones nearly a century before those words became common in precision agriculture conversations. The machine was expensive to operate and maintain, which ultimately limited its commercial success. But the concept, absolutely visionary. Number 9. The Minneapolis-Moline UDLX Comfortractor. Most tractors in the 1930s were brutal to operate. You sat on a metal seat, exposed to wind, rain, dust, and exhaust fumes. Comfort was not a word used in tractor marketing. Then Minneapolis-Moline released the UDLX Comfortractor in 1938, and it changed the conversation entirely. This tractor came with a fully enclosed steel cab, with a heater, a padded passenger seat, a radio, a speedometer, turn signals, and even a rearview mirror. It could travel at speeds up to 40 miles per hour on the road, which was extraordinary for a farm tractor at the time. Minneapolis-Moline marketed it as a machine you could drive to town on Saturday and plow with on Monday. The idea of an operator comfort-focused tractor with a climate-controlled cab wouldn't become industry standard until the 1970s and beyond. John Deere's first modern enclosed cab tractor, the SoundGuard body on the 1972 John Deere 4x3, came over 30 years later and was celebrated as revolutionary. Minneapolis-Moline had already been there. Unfortunately, the UDLX was expensive. At $2,155 in 1938, it cost nearly twice as much as comparable tractors. During the Great Depression, most farmers simply couldn't justify the price for creature comforts. Only about 150 units were ever sold, making it one of the rarest production tractors in American history. Today, surviving UDLX Comfortractors are prized collector items worth well over $100,000. Number 8. The Ferguson TE20 and the 3-point hitch system. Harry Ferguson might be the single most influential figure in tractor history that the average person has never heard of. His Ferguson TE20, affectionately called the Little Grey Fergie, was introduced in 1946 and came equipped with Ferguson's patented 3-point hitch system with draft control. Here's why this was revolutionary. Before Ferguson's system, implements attached to tractors were essentially dead weight that dragged across the ground. If the plow hit a rock or hard soil, the tractor could rear up and flip, killing the operator. Ferguson's 3-point hitch used a hydraulic linkage system that automatically sensed resistance on the implement and adjusted the working depth in real time to maintain consistent draft force. This kept the tractor stable, protected the engine from overload, and dramatically improved tillage consistency. The system was so effective and so fundamentally correct in its engineering that it became the global standard. In 1961, the Society of Automotive Engineers adopted a standardized three-point hitch specification based almost directly on Ferguson's design, and today virtually every tractor on Earth uses a version of this system. Ferguson developed the concept in the 1920s, demonstrated it to Henry Ford in 1938 with a famous handshake deal, and eventually brought it to mass market with the TE20 in 19. The three-point hitch wasn't just ahead of its time, it defined what a tractor would be for the next 80 years and counting. Number 7. The Allis-Chalmers Model G. In 1948, Allis-Chalmers introduced a tractor that looked completely backwards because it literally was. The Model G was a rear-engine tractor, meaning the engine sat behind the operator instead of in front. The driver sat at the front of the machine with a completely unobstructed view of the implement working the soil directly beneath them. For vegetable and specialty crop farmers who needed precision cultivation, working between rows of lettuce, onions, or strawberries without damaging plants, this design was a game changer. You could see exactly where your cultivator tines were going. No guessing, no craning your neck, no crop destruction from blind cultivation. The concept of putting operator visibility and ergonomics at the center of machine design was decades ahead of mainstream tractor thinking. Today, specialty crop tractors and high-clearance cultivation equipment routinely prioritize sightlines and precision positioning, ideas the Model G championed in 19. The Allis-Chalmers G used a Continental N62 four-cylinder engine, producing just 10 horsepower, which was modest even then, but perfectly matched to its niche. It remained in production until 1955 and is still used by small-scale organic vegetable farmers today who value its unique visibility and low weight. Number 6. The DOE Triple-D. Dual drive. If you've never seen a DOE Triple-D, prepare yourself. Built by Ernest Doe & Sons in Essex, England, starting in 1958, the Triple-D took two Fordson major tractors and connected them front to back with a pivoting coupling unit. The result was an articulated four-wheel drive tractor long before the major manufacturers figured out how to build one. The front tractor unit was stripped of its rear axle and bolted to a pivot frame. Both engines, one in front, one in back, powered the machine simultaneously, delivering exceptional pulling power in wet, heavy English clay soils. The articulated steering allowed it to turn with surprising agility for such a large machine. Articulated four-wheel drive tractors became one of the dominant designs in large-scale farming by the 1970s and 1980s. Think Steiger, Versatile, and John Deere's articulated 4WD lineup. Doe was building the mechanical concept in a small workshop in Essex nearly 2 decades earlier, using two production tractors bolted together as a practical solution to a real problem. About 300 DOE Triple-D tractors were built before the major manufacturers started offering factory-built four-wheel drive articulated machines, making them obsolete. But the engineering logic was proven, practical, and completely sound. Number 5. The Lanz Bulldog. The Lanz Bulldog is one of the most iconic European tractors ever made, and its engineering was genuinely strange in the best possible way. Introduced by Heinrich Lanz AG of Mannheim, Germany in 1921, the Bulldog used a single-cylinder, two-stroke hot bulb semi-diesel engine that could run on virtually any combustible liquid: diesel, crude oil, vegetable oil, used engine oil, even coal tar. This fuel flexibility was extraordinary. In the 1920s and 1930s, diesel fuel wasn't always available in rural areas across Europe. A tractor that could run on whatever flammable liquid the farmer had available was incredibly practical. The engine had no electrical ignition system. It used the heat of a preheated bulb to ignite fuel, which meant fewer things to break and simpler maintenance. The concept of multi-fuel or flex-fuel engines for agricultural machinery became a serious area of research in the 21st century as concerns about fuel costs and energy independence grew. Researchers studying biodiesel and vegetable oil as tractor fuels were essentially rediscovering what Lanz had already solved in the 1920s. The Lanz Bulldog was built in large numbers until 1960, when John Deere acquired Heinrich Lanz AG. Some of these machines are still working in fields across Europe today, nearly a century after they were built, a testament to how robust the design really was. Number 4. The Oliver Super 99 GM. In 1954, Oliver introduced a tractor with a power plant that was completely unprecedented in farm equipment, a General Motors 3-71 two-stroke diesel engine, a supercharged blower-fed engine originally designed for trucks and buses. The GM 371 was a 3-cylinder 113 cubic inch engine that used a Roots-type supercharger to force air into the cylinders on every stroke. This gave it exceptional power density and a distinctive sound, a high-pitched mechanical scream unlike any other tractor engine. The Oliver Super 99 GM produced around 70 drawbar horsepower, making it one of the most powerful row crop tractors available in the mid-90s. Forced induction, turbocharging, and supercharging is now standard on virtually every modern diesel tractor. Turbocharged engines became common in agricultural equipment through the 1960s. Oliver put a supercharged engine in a production row crop tractor in 1954, years before the industry accepted forced induction as a viable approach for farm machinery. The Super 99 GM was expensive, and the GM engine was more complex than conventional tractor diesels, so it didn't become a mass-market product. But it demonstrated that high-output forced induction diesel power was completely viable in a tractor platform, a lesson the whole industry eventually learned. Number 3. The Allis-Chalmers Fuel Cell Tractor. In 1959, Allis-Chalmers demonstrated a working tractor powered by hydrogen fuel cells. Not a concept drawing, not a laboratory experiment. A working field-driving tractor powered by 1,008 individual alkaline fuel cells, generating 15 kilowatts of electricity to drive the wheels. The tractor was developed in partnership with the U.S. Army and used a system where hydrogen and oxygen reacted in the fuel cells to produce electricity with water as the only byproduct. Allis-Chalmers demonstrated the machine pulling implements at the Wisconsin State Fair to show that hydrogen fuel cell technology was practical for real-world applications. This was 1959. Hydrogen fuel cells as a viable power source for vehicles, heavy machinery, and agricultural equipment became a major research priority in the 2000s and 2010s. Multiple tractor manufacturers and agricultural technology companies announced hydrogen fuel cell tractor programs in the early 2020s, more than 60 years after Allis-Chalmers had already proved the concept on a real farm tractor. The technology wasn't commercially viable in 1959 due to the cost of hydrogen production and the complexity of the fuel cell systems. But the engineering proof of concept was real, documented, and extraordinary for its era. Allis-Chalmers was having conversations about zero-emission farm power before the term zero-emission was part of anyone's vocabulary. Number 2. The Fendt Favorit 612L. With the Vario CVT transmission, continuously variable transmissions, CVTs, allow a tractor to operate at any speed within its range without distinct gear steps. Instead of shifting between fixed gears, the transmission infinitely adjusts the ratio between engine speed and ground speed. This means operators can set the exact field speed they need for any operation, and the engine can always run at its most efficient RPM regardless of ground speed. Today, CVT or stepless transmissions are considered premium technology available from every major manufacturer. But Fendt, a German tractor manufacturer, introduced its Vario continuously variable transmission on the Fendt Favorit 612LS in 1995, making it the first production agricultural tractor in the world with a full CVT powertrain. The Vario system used a combination of hydrostatic and mechanical power paths to achieve a continuously variable ratio across the tractor's entire speed range, from near zero to maximum travel speed, without any clutching or shifting. The operator simply set the desired engine RPM and speed, and the transmission managed everything else. The industry response was initially skeptical. CVTs were more complex and more expensive than conventional power shift transmissions. But within 15 years, virtually every major tractor manufacturer, John Deere, Case IH, New Holland, AGCO, Claas, had introduced their own CVT systems. Fendt's Vario was the template they all followed. Fendt had essentially built the future of tractor drivetrains in 1995. They were right, and eventually the whole world agreed. Number 1. The Ford 8N with position control hydraulics. Our number 1 pick might surprise some people because the Ford 8N isn't a rare or exotic machine. Over 524,000 of them were built between 1947 and 1952, making it one of the best-selling tractors in American history. But inside that simple gray and red package was a hydraulic system with position control capability that changed tractor engineering forever. Building on Harry Ferguson's three-point hitch system, which Ford had licensed since the famous 1938 handshake agreement, the Ford 8N combined draft control with position control, giving the operator precise, repeatable control over implement depth. You could set an exact working position, and the tractor's hydraulics would maintain it automatically, compensating for variations in terrain. This feedback-based hydraulic control, where the machine continuously monitors and adjusts implement position based on sensor input, is the direct ancestor of modern precision agriculture technology. Electronic draft control, GPS-guided implement depth management, automatic section control on planters, variable rate application systems, all of these are conceptual descendants of the closed-loop hydraulic feedback system Ford and Ferguson put on a mass-production tractor in 19... The 8N proved that automatic feedback control of implements was practical, affordable, and enormously beneficial to farmers. It didn't require advanced electronics or computers, just clever mechanical and hydraulic engineering. It demonstrated a principle that the entire precision agriculture industry would spend the next 75 years elaborating and digitizing. And it did all of this at a price farmers could actually afford. The Ford 8N sold for around $1,200 in 1948. In doing so, it put revolutionary agricultural technology within reach of ordinary American farms and set a standard the industry has been chasing ever since. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.